So we're looking at optimization, obviously, predominantly in a geometric and an abstract term. Now we're going to start looking at it as a rate of change and specifically in a business context. So, before we do anything with optimization, we need to understand a few key terms such as profit. What is profit?
The amount of the business, so like the amount you bought, like unit for, minus the amount you sold. No, the amount you sold it for minus the amount you bought.
Okay, so you've said the amount you sell it for minus the amount you cost to make or cost to build. So money in minus expense. We use more effective terms or more precise terms in the financial world. Revenue minus cost, something like that. Now, profit, what's the most important thing when you're running a business? Is it how much money that enters and leaves your business? What's the most important thing? Customers. You want to make the most money you can possibly make, correct? That is profit. Okay, whether you have $1 million coming in and $1 million going out, have you made any money? So it's better to have a business where you're making 50 cents than one where you're making none, correct? So profit is really what the heart of all these businesses are trying to get to. Maximising profit. So how do you think right now we can use optimisation with business? What are you thinking? How do you do that? How would you use optimisation to find a maximum? You need a rule. So you need a rule in terms of money. Does it? Cost and revenue. So revenue. How much money will you make if you sell 10 chocolates for $2? How much money will you have coming in? Doesn't matter. Just revenue. Revenue. How much revenue is coming in? 10 chocolates, $2 each. How much revenue? $20. How do you figure that out?
10 times 20.
10 times 20. So you need the number times by the product, the cost of the product. Cool. You can use whichever way you want. It doesn't really bother me. They're represented as N times P in the book. Doesn't matter. However you want to represent profit. Most of us have got our head around it. What do you think this stands for? PN equals RN minus CN.
Profit equals revenue.
Profit per number equals the revenue per number minus the cost. Correct? So they're all functions of the number of products we're selling. Really good. I think we get that. That leads us to, I'm going to start with question 2.
So the P equals what?
The number of, the cost per unit. What do you reckon? The number of units.
So P is the cost.
So P was our $2.
So can you write out all the
Yeah, I will. Yep, I will. I'll go through this question, then I'll come back to it. I don't actually think you need a lot of this once we get our hand ready. I'm just showing you how it's represented in the textbook. Every person in the room identified that the profit was $20 with the chocolates. Not the profit, the revenue was $20 because they said 2 times 10. So you intuitively know that's how we calculate revenue. So here's question 2. It gives you, it doesn't matter about anything else. It gives you, they sell for $4 per unit and the cost is described by. So firstly, what does that function CX tell us? The cost per item, cost of the item in terms of? What's that variable X talking about? The number of? Products, items, units. So what would our RN be? What do you think RN would be? Or RX, sorry, not RN. What's RX going to be? For what? 4x, correct? You will make $4 per unit. So 4 times X will be our revenue, won't it?
Yeah, wherever at X and you still want how many items there are.
Yep. So now we need to find a maximisation because at some point, what does this function look like? What does the cost function look like? Parabola? quadratic, it's fine. Quadratic's correct. It's another name for it, parabola. So it's going to be like a smiley face. This one is a straight line. So this one won't grow by as much as this one, will it? As we go further and further away. So how will we set up this problem? What's the steps to setting up this problem? We want to get a maximum or a minimum for the profit, correct? So what do we first need to do? Before we derive, can we derive?
Have another equation.
What's the other equation we need?
Profit.
The profit equation. So profit equals what? What's Rx minus? Now this is where I want to address a misconception. Because what a lot of you are going to do is you're going to write 4x minus 50 plus 1.3x plus 0.001x squared. That's right, isn't it? Ah, I need the bracket. Why do I need a bracket? Because I've only applied the negative to the 50, haven't I? You need to be very aware of the fact that negative applies to all three terms. That's a misconception I see all the time. So when you put the negative into every term, you get 4x minus 50 minus 1.3x minus 0.001x squared. That is px. Can I do anything here?
Yeah.
What can I do?
4x minus 1.3x.
Collect like terms. So what's 4 minus 1.3?
2.7.
2.7x minus 50 minus 0.001x squared. Now what do you think we need to do? Calculator is always the answer, isn't it? Derive it. Why do we want to derive it? So that's, what's that function there? What is that? It's a parabola. What is it? So that's going to be a negative parabola. It's going to look something like this. Correct? What do we want to find? We want to make the most money. Where's that going to occur? Turn this over here. Okay, so we want to find this point here. We could trial and error, find out, getting higher, getting higher, getting higher, getting lower, getting lower, getting lower. What's the problem with that method? Bad communication, inefficient method. How much time you got in your exam? Enough time to...
So just let x equal 0.
Just let x equal 0. The answer is negative 50. What's 2.7 times 0? So what's the step that Adam's missed? He's not let x equal 0. I need to derive it. Why am I trying to derive it? I want to find when the tangent equals 0. Because when the tangent equals 0 on this function, I'll have the max, won't I? Happy with that? So I find my tangent. How do I find my tangent? What do I derive? So I could write... That's exactly right. That's why we did this second, not first. How do I derive that function? 2.7 0.002x. Very good. Let p dash x equals 0. Once I've done that, then I can double derive it. But let's find my point first. 0 equals 2.7 minus 0.002x. What should I do here? Chuck it on your calculator. Shouldn't I rearrange this first and isolate my unknown variable x by adding 0.002x to both sides, which would get me 0.002x equals 2.7. How do I isolate my x now? Divide both sides by 0.02. 0.02. Now what do we do, Adam? Oh, very good, Adam. Chuck it in your calculator. I know, I was being facetious. What is that? 1,350. Was it exactly that?
Correct.
What would you do if it wasn't exactly that? Okay. What were we trying to find? What's X represent?
Where the maximum.
This is when the maximum occurs. The amount of what? Yeah, amount of units product. So that's what we find a maximum. When we make 1,330 or 50 units.
It doesn't give you like dollars or something.
Yeah, well, whatever they give you. But that's not $1.
No.
You'd round it, correct. Why would you round that if it wasn't a whole number? You can't sell half a chocolate bar, can you? You can't sell a quarter of a fridge. Why?
If you jack out, you can sell it.
Okay. So if you feel like writing that in your exam and rolling the dice, go nuts. For the rest of us, I suggest that if you get to a decimal value of a whole unit, you round it up or down depending on which one you're closest to.
So would you write out?
I'd write my answer, and then you'd say, yep. And that would show that you understood the problem probably. So if I had, say, 1,349.7, I would say X equals 1,350, as you cannot create 0.7 of a unit.